So now that we've seen how a basic exponential graph looks using a table, we want to learn some sort of a shortcut. And I'm going to leave this up here. I'll come back in a second. But I want to take a look at this example here from our last video. The point 0, 0, that's usually where we start our graph off at with all the other types we've done, and we always go up 1 over 1 to start out on our parent function. That didn't work on these examples. So exponentials kind of need their own rules because the usual stuff we do isn't going to be as helpful here. So anyway, I wrote down a few things. The horizontal asymptote, the tail of your graph, is going to be at y equals 0, which we saw on both of our examples. And there are 2 points that are going to be on the graph that we can use. You need at least 2 points to make an exponential graph in addition to the asymptote. 0, comma a and 1, comma a times b. Those 2 points are what we're going to use to actually make our graph because they're easy to find usually. Let me go ahead and you'll see how this works and why it makes sense when we start doing our examples here. So there are my rules. I'll try to leave those on the screen. But I want to graph y equals 2 times 3 to the x. So what I'm going to do to start things off here, I know there's going to be an asymptote on this graph, and I'm actually going to draw it in with like a little dotted line so I know where the tail on my graph is supposed to go. As long as I don't move my graph around, which there's no pluses or minuses moving things here, that asymptote, the tail, goes at 0. So what I'm going to do is I'm going to draw like a little dotted line here at y equals 0 to remind myself that that's where the tail of my graph is going to go. So I drew in like a little line that'll show me where my graph levels off. The points I need are first I'm going to do 0, comma a. So if I plug in a 0 for x, what's going to happen here is I'm going to have to do 2 times 3 to the 0 power. PEMDAS, I do my exponent first. 3 to the 0 power, anything to the 0 power is 1. It goes away. So my answer is going to be 2. When I plug in a 0 for x, I get out a 2 for y. So I need to plot the point 0, comma 2. And I also need to pick the points 1, comma a times b. If I plug in a 1 for x, this is just to the first power. So I just get 2 times 3 is 6. So 1, comma 6 is also on my graph right here. I've got 2 points. And I know my graph has to tail off along this line right here. If I go this way, I'm doubling back over my graph, and that's no good. So I know I just kind of follow the flow of my points. It's going to get really, really big, but then it's got a tail going something like what you see right here. It kind of tails off along the line. That would be my graph. And I didn't remember to write it down here, but we can still add it in. The domain of my graph is going to be all real numbers because it's keep going left and right. And my range is going to be y is greater than or equal to, or technically in this problem, strictly greater than 0, because it goes from 0 upwards right here. Let's look at another example. We have 8 times 1/4 to the x. And looking at this one, because we have a 1/4 right here for b, I can tell already it's going to be exponential decay. My graph's going to be going downwards as I go along. But let me draw my little grid. And again, I realize, my grids are kind of sloppy here, but I realize I'm going to have an asymptote at 0. So I'm going to draw in a dotted line here to remind myself, hey, this is where my graph tails off. So once I want to make my graph, I need my 2 points. So I'm going to start out with 0, comma a. I'm going to plug in a 0 right here. When I plug in a 0, this goes away. I just get out that number. So I need to plug 0, comma 8. 5, 6, 7, 8. That's on my graph. The second point I'm going to use is 1, comma a times b, because if you plug in a 1, you just get this times this is 2. So 1, comma 2 also on my graph. I've got my 2 points. It wouldn't make sense to tail off this way because I'd be doubling back over my graph. So it's going to look something like this. I kind of use the asymptote to guide my graph. Domain on this one is all real numbers. Range, also y is greater than 0.